Hi guys, welcome to Scholastic Home Video Tutor. In this lesson, we are going to look at AQA Mathematics Statistics MS SS1B May 2011 examination, question number 2. Let's read the question. The diameter D in millimeters of an American pool ball may be modeled by a normal random variable with mean equal to 57.15 and standard deviation equal to 0.04. Part A, there are two parts in part A determine, and part B, there are two parts here. Part A is about 5 marks, part B 6 marks. Let's go through the question again. So what we found was that mean 57.15, standard deviation 0.04. As usual, we can represent the diameter as a normal distribution with mean 57.15 and variance is the square of standard deviation 0.04 squared. So what we need to find out is the probability when the diameter is less than 57.2. So normally we can see it in a picture form. Basically this is the normal distribution. The mean is 57.15 and 57.2 lies somewhere here, 57.2. So what is the probability? The total area is 1 and this is the area what we want to find out. The probability of the diameter less than 57.2. So what we need to do is we need to use the tables given. So if you look at the table number 3, which is normal distribution function, the probability can be found under the curve up to Z here. So this is the total probability, but make sure this is mean 0 condition. So what we need to do is that our mean is at the moment 57.15. So we need to convert it to mean 0. That means we are going to find out new variable Z in which what is the value of 57.2 if you convert the mean to 0. So what we know from our basic theory is that Z or the new variable is equal to x minus mu divided by sigma. In this case, let's assume this diameter is a random variable. It is given as x here. So Z is the one that we need to find out. So basically the value of 57.2 can be converted to mean is 15 divided by 0.04 is a sigma, which is equal to 1.25. So basically our equation now reduced to probability of diameter less than 57.2 is equal to probability of Z less than 1.25. So instead of reading D or variable x in this case, we can read Z with mean 0 in this table. So what we now have to do is go to the value of Z, which is equal to 1.25. This is 1.2, 1.25 here. So we got the probability here, that is when the value of Z equal to 1.25, the total area under the curve is equal to 0.89435. So if you approximate this to 3 decimal point, it will be 0.89423 decimal points. This will be worth about 3 marks. Okay, that's simple. Okay, let's go to part 2. Part A, part 2. Now we need to find out the range of it. The diameter is in a range 57.1 to 57.2. So again, if I draw a simple sketch here, so our normal distribution, our 57.15 is mean, and this is 57.2 we just now found the probability the area under this curve. And now we have another line here 57.1, which which is less than the mean, therefore it's here. So what we need is the area in between. So same case here, for the case of first part, we can actually find the total area from here up to here, which is equal to probability diameter less than 57.2. We got this answer from the previous part, which is equal to 0.89435. And now we have to find out the new area, basically this area, which is below 57.1. So that means the probability of D less than 57.1, and again we can find the value of Z. Z is less than 57.1 minus 57.15 divided by sigma 04. So okay, what you get here is that the probability of Z less than minus 1.25, which is actually in here. If you look at minus 1.25 is here, so basically instead of finding this area, we can find the total area minus this one. Basically we can write 1 minus probability of Z less than 1.25. So basically instead of finding the negative value in this graph, you find from the positive value, which is 1.25, and then take away that from 1, so which actually we found earlier. So that means this will give us the probability between 57.1 and 57.2 is equal to the value is total area from here up to the 0 is 0.89435 minus 1 minus again the same value, 1 minus 0.89435. This is the area from here, this area. So once you subtract the small area from the big area, so you get the area in between. So you can simplify this one and find out the value to be equal to 0.789 to 3 decimal points, which will be about 2 marks. Okay, so that is the part 2 of part A. And now we'll look at part B, in which it says that a box contains 16 of these balls. Given that the ball may be regarded as a random sample, determine the probability that 16 balls have diameters less than 57.2 millimeters. So what we found from the previous part is that the probability of getting a ball with diameter less than 57.2, probability of diameter less than 57.2 is equal to 0.89435, which is our probability P1. Now it says that we take 16 balls randomly from those pool balls. That means we take the first pool ball, second pool ball, then the probability of first pool ball to be less than 57.2 millimeters is P1, and then you take two of them, both of them to be less than 57.2 is P1 times P1. Like that we take 16 balls, 1, 2, 3 up to 16 balls. All these balls will have a probability of P1, that is if the ball to be less than 57.2 millimeter is about P1. So then the total probability of having all 16 balls with diameter 57.2 or less is equal to P1 to the power 16. So that will be 0.89435 to the power 16. So using the calculator you can find out the value to be equal to 0.168 to 3 decimal points. This will earn you about 2 marks. Okay, let's go to the last part of the question, which is actually 4 marks question. So which will be, now we need to find out the diameter of, so the same conditions given, and the mean diameter of the 16 bolts is greater than 57.16. So when you come to this part, is mean diameter means we have a population, you take a random sample and we are looking at the mean of that random sample, which is actually central limit theorem. So what we know is that the original mean mu is equal to 57.15. Therefore the sample mean also same. There is no change in sample mean, which is equal to 57.15, and the original standard deviation is equal to 0.04. Therefore sample standard deviation, that means we have a population with a standard deviation 0.04. When you take a random sample of some length of, in this case 16 is the length of the sample, then what is the sample standard deviation, which is actually given by sigma over root 10. This is the definition you can use as it is. So actually the value of new sigma is equal to 0.01. So that is the standard deviation. Okay, now what we want to find out is of the 16 balls, mean of the 16 balls greater than 57.16 millimeters. That means probability of mean diameter of the 16 balls greater than 57.16. Again we need to convert this to our new variable, that means z, which is equal to greater than 57.16 minus mean is 57.15 divided by the new standard deviation is 0.01. So which is equal to probability new variable z greater than 1. Again we have a condition where we have to find the probability of z greater than 1. So the mean is 0 and 1 is here, so this somewhere here. Now so when you read the graph we can only see this area. So what you do is 1 minus probability z less than 1. So what we do next is read the probability, normal probability distribution graph function, in which the value of z in this case 1, and the area under that, that means z become 1 up to z1, the what's the probability, which this one is equal to 0.84134. that means 1 minus, because what we need is the area of z greater than 1, this one, this area, that means 1 minus 0.84134. When you reduce the, when you simplify here, you'll get the answer to be equal to 0.159 to 3 decimal points. So this will be about 4 marks. This is 4 marks question. Okay, so finally we came to the end of the AQA A Statistics MS SS1B June 2011 question number 2. Thank you very much.